Okay, so Calc Final, it's probably going to take us 3 days to get through this review, and then I'll piece this together into one like ginormous video later, I think. When we take the test, I usually just give you a whole week to take that. 4 days is probably sufficient, but I know about what your attendance is, you guys, and you understudy, so we'll probably just give it a week and take how it goes. I couldn't find my results paper. My vibe on this historically is that this goes well. There's 2 reasons for it to go well. One, and then I potentially add in a third. One, some of this stuff is things that we've been using all year, so it's not a matter of even like, how do I do the quotient rule? Like, you still should remember how to do the quotient rule. So when you get a basic quotient rule problem, that should seem easier than some of the crazy involved quotient rule problems we've done. Second thing, at some point, for some reason, I built in some cushion into this, so I think you got a piece cut off on purpose. Does your thing stop on a page that's going to like 127? Something like the last problem, 127. But there's more stuff on that page.
It goes to 129.
Okay, so we're actually stopping at 127. There would have been other stuff from chapter 7. Once upon a time, early in my career, I used to do chapter 7 and then do the final, but I reconsidered that, and now we do the final and then probably chapter 8 for reasons that don't matter right now. But once upon a time, this was out of 202. The new version of this is now out of 184. So at some point early in the going, I built in a little bit of cushion and didn't count it out of true perfection. But I think people since those first few years have surpassed it. But I just left it the way it was. So what this will get counted out of, instead of 184, is 170 and a half was like the percentage basis of how I decided to just make a total for this. But a lot of people, since I made that the basis, were better than people who were before that decision was made. And I just let people go over 100% sometimes on this, because that's like an achievable goal for the better folks. I do count everything double, so it's not, when I first score it, it would be out of 170 and a half, but then I double count all my finals. So this is out of 341, which is a very strange total. But a truly perfect paper would be a 368. And like I said, I can't find my data paper for some reason. It's gone missing out of my folder. It probably got misfoldered, and I'll find it someday somewhere else. So what's the best score ever? I don't know. Is this usually A's? I think there's usually a fair amount of A's with some B's on this. I don't feel like this usually goes badly, but I don't know. That's the reasons for it. The other reason this usually goes well is I try to capture your attention by pointing out, like, it's a 341 point test in a class that right now we've had like 1,000 points in the year. So that's like a lot. That's important. So that this is not a like show up and hope for it. This is like a study for real for this test. I'm not trying to mimic college life, but I am always a little bit trying to prepare you for college life. I absolutely had college classes where the final was worth as much as like 60 to 70% of my grade, which I thought is the most ridiculous way to grade in the history of grading. But I don't get to choose that because I'm just a student in the class. But I absolutely had things where it's a 15-week semester and I've spent 14 weeks and 4 days achieving a certain level of performance, and what that's worth is like 30% of the total grade. And the final could just like make or break me, and I thought it was ridiculous, but I couldn't control that. So 300 points, 341 points should definitely capture your attention, but since we have had 1,000 points on the year, that is a lot, but it isn't going to make or break you. But it could make or break whether you got like an A or B for the year. It can make or break things like that, but it's not going to make or break you like turning you into an F or something. But question about structure and whatever. You'll take this kind of like you took the 7th grade math test, other than I don't grade it till you're done. Like 7th grade, I used to check it kind of as you did it, and you gave me permission to check certain pages. I'm not going to do that. I'm going to wait till you're all done and just check the whole thing. But if you leave blanks and you skip and you come back and you leave and you return and you get this day and this another day, that's all fine. What you can't do is show up to do one problem, okay? Because then that turned it into an open notes test, and I'm not interested in an open notes test. What you should be thinking in terms of doing when you do this is like a full page or more. Not like I'm gonna show up and do 1 or even 2 or 3 problems, but like if you come in and do a whole page of integrals, I'm okay with that. But we're not looking to make this be like, I'm gonna study my packet. Now I do 1 problem. Now I'm gonna study my packet. Now I'm gonna do 1 more problem. Like that's dumb. That's not a real test. We're still trying to take this more like a real test than not take it. Anything about structure? Okay. So here's another helpful tidbit. You might want to expand your card because there are things on this, like number 1, that when we learned this, you didn't have a card. But it's the type of thing that is fair play to put on your card. So for number 1, if you don't remember what the distance formula is with all the like x's and y's and roots and stuff, put that on your card. For number 2, if you don't remember the slope formula, put that on your card. For number 3, if you don't remember the point slope form of an equation, what that is, put that on your card. If you forgot about y equals mx plus b, put that on your card. And so on and so forth. You get my point. But when we first did a lot of this stuff, you didn't have a card. So what's fair play for your card is anything that's fact-based. Anything that's like a formula you would look up in a book. You can put that on your card. What you can't put on here is like example problems or sentences in English that describe how to do something. That's not fair play. But here we go. 1 is the distance formula. If you don't know it, I'll tell you what it is. It should be root 34 as an answer. 2, you just need to know a slope formula. We're hoping for -3/5. 3, you need to know how to work point slope form. And then I would get everything y equals. So if you have something like y plus 2 equals and a distributing looking problem, that's decent to start with, but I would like that to get distributed and y get isolated. That's y equals 3x minus 5. 4, I just went straight into y equals mx plus b. Y equals -2/3 x plus 1. 5 is like a combination of 2 and 3. You have to figure out the slope first, which is 2. Then you have to do that y minus y coordinate point slope form like we did in 3 and get it distributed and whatnot. That's y equals 2x minus 9. 6 is pretty much just like 3, except you have to get the slope figured out. What's the slope on 6? It is 3, because I can see a 3, and parallel means to keep the slope the same. So you're going to have like a distributing looking thing with a 3 distributing in there. Y equals 3x minus 8. 7, you also have to figure out the slope, but it's not 4, but it's based off of 4. What's the slope from 7?
-1/4.
-1/4, because perpendicular meant negative reciprocals. So a -1/4 is distributing. Grand total, y equals -1/4 x plus 8. And all of that would be single pointers. So, well, everything gets kind of doubled. So I guess that's a 14-point page, but there's no like hidden points in that. It is what it's numbered. Other problems are worth more points to begin with, and I'll highlight that as we go. First face, anybody want me to tell you any formulas that you can put on cards, need run through, so how to work any of this? What are we gonna do?
Distance.
Distance formula, go distance equals square root surrounding everything else I'm going to say, parentheses x1 minus x2 getting squared, plus, in parentheses, y1 minus y2 also getting squared. Not fair play would be to put an English description, but my English 4-step description is basically subtract, and then Pythagorean theorem, it's square add root. X's subtract X's, Y's subtract Y's, and once you get those subtracted, just square them, add them, root them. The distance formula is essentially getting the hypotenuse with the Pythagorean theorem.
Okay. And
More,
then
anything?
slope.
Y, maybe delta Y over delta X, or if you'd rather, Y1 minus Y2 over X1 minus X2. There's other ones too that can work, rise over run. That's probably the best two formulas. Anybody else either want me to tell you what a formula is that's card worthy, or explanation of how we jump through the different hoops and steps on our way here?
What's the point slope form?
Point slope is y minus the y coordinate, which on this paper I wrote y with a subscript of 0, but I sometimes write that y with a subscript of 1. But the letter y minus y with a subscript equals m, and then in parentheses x minus x with a subscript, whether that's a 0 or a 1, kind of depends on your mood at the time. But the x1, y1, xo, yo thing, that's like the actual numbers I'm giving you, and the x and y are like the letters x and y. It's always y minus this equals slope, parentheses, x minus that, where we know this and that. More to 7. Okay. Next, face, domain and range is not our all-time favorite thing. So there's nothing really here that's card worthy or card ability. But what you need to know is that the domain's what you're allowed to put in for X. And I'll answer those two questions first, and then I'll talk about the range. The domain for 8 would be 2 with parentheses next to it, comma, infinity. So it's written like an ordered pair with parentheses, 2, comma, infinity. So my thought process there is I can't put in 2 because
It'll be 0.
it'll be 0 on the bottom. I can't put in anything less than 2 because I'd be rooting a negative. So I'm going to go 2 with parentheses to not include it. If I want to include the 2, what punctuation gets used?
Is it a bracket?
It's a bracket. So if the 2 itself could work, I'd put a bracket to be next to the 2, but that wasn't the case. So parentheses, it's 2 and up. So 2, comma, infinity. For 9, 9, the only bad boy number is 0. So we have to write the domain in 2 portions. We'd go the negative portion and then the positive portion. 0 can't be used, so I don't use brackets. So I go parentheses, negative infinity, comma 0, and those parentheses, a U for union, and then another set of parentheses, 0, comma, infinity, and that's my domain info. Question about domain? Range is what can come out. So we're thinking about what y's can come out of this for range. So for 8, we can't get 0 out because 1 divided anything, there's always going to be at least a speck of something left. We can't get a negative out because when the radical sign gets used, the ruling on radical sign usage is only positives come out. So the range is parentheses 0, comma, infinity. For number 9, what could come out? Well, analyze the fraction first. 1 dividing stuff can't get you 0 for that moment. But if we're adding 4, that means you could never get a final answer of 4. Any other answer would be possible, but not 4. So that's going to look pretty much like how the domain looked, but it'll have a 4 instead of a 0. So we go parentheses, negative infinity, comma 4, close the parentheses, a U for union, and then another set of parentheses with 4, comma, infinity in them. Plan B, graph it on your calculator. The domain is going to be shown to you by the X coverage, and the range would be shown to you by the Y coverage. So, quick sketch graph here. If we did sketch this, if the domain is 2 to forever, that would mean it would look something like this for you. That it starts at 2, and you can literally see it goes forever. That's a way that you could read the graph. And then the range, if you look this way, it starts on the axis and goes forever. That would be a way you could interpret the range as well. You'd have to realize if the graph didn't show you that there's a hole in the graph there, you'd have to figure out that that point itself is a bad news point because you're not allowed to put 2 in exactly. So that might take a little bit of an analysis, but that's a plan. If you want my best advice, which I'll give it to you whether you want it or not, I would suggest you do those problems by thought process and then you check them with graphing. And if they agree, you are right, and if they disagree, you set it aside and come back the next day after doing a little research on domains and ranges. 10, best way to do these is to insert next to the 4 an x with a power of who do you think? Anybody a guess? Write it as 4x to the
2.
lie. 0, true. Because x to the 0 is the same as 1. So putting in an x to the 0 next to that 4 is harmless. And I would do that. Then the simplest way to do these problems is if all of the powers are even, say even. If all of the powers are odd, say odd. And if you get a mixture,
Neither.
say neither. I would do a similar attack on 11. Next to the 1, I'd pencil in that as x to the 0. So number 10, based on that ruling, would be, number 10
Oh, even.
was even. 11
Neither.
is neither, neither. You say neither, I say neither. You say potato, I say potato. Let's call the whole thing off. If you just saw an x, that didn't happen here. If you just saw an x, x has a 1. 8 and 9, I don't know that the test would have no brackets on it. This might have just been a coincidence, so be ready to do a bracket. Again, we use the bracket for what?
Including the
If
number.
we're including that number. Something to 11. 12, I have in mind that this exists for you to do from your mind, not from your graphing calculator. Because if you do it with your graphing calculator, that's like the stupidest section ever. I have in mind that this is like a mental math section, and I just have to kind of trust you, because if you cheated me, I don't know how I'd catch you, other than taking your calculator away for this page, and I think I'd rather just trust you. But, 12, how would you do that with mental math if you are banished by your machines?
Up 3.
Up 3, make a first dot on the y-axis.
Right 2.
Close.
Up 2.
Up 2 over 1 from that dot. I agree. 13, you need to know that squares make what shapes? U's. And then the plus 4 just pops you up 4. So just go up 4, make a dot on the y-axis, and make a random U. 14 looks like the Jackrabbit roller coaster. It's like with the double dip. It's half of a U filling quadrant 1. It's another half of a U filling quadrant 3. Put that together and you've got that graph. 15 is a half U that's been leaned on its side. So it's this. If I had touched the origin, that's what the square root graph should look like. 16, somebody follow Nicole's advice of what she did on 12. Where would you go first on 16?
Down 2.
Not first.
Up 4?
Up 4 to make the
Oh,
initial
well, yeah.
dot, and then from that
Down
dot,
2.
down 2,
Right
and
3.
right 3 to make another dot. 17, like 13, it's just instead of nudged up 4 from the origin,
It's down 2.
it's down 2. Anybody an opinion on 18, what happens?
It's right 3 and sideways.
Yeah, it's gonna, when I switch X and Y, we just go nap time for our U and it goes sideways. And that plus 3 just nudges you 3 squares to the right. 19 should be like a sort of a shape like this that fills quadrant 1. And then a matching shape like that fills quadrant 3. If you want to look at my shapes, I'll just lend them to you. 20 should look like a funnel. It's basically 2 things like this that won't touch any of the axes, but they basically fill column 1 and column 2. once upon a time, we did basically memorize how to do all of those graphs in the max-min chapter with dominant terms, and we graphed with dominant terms. Like at once upon a time, that those were all like in our memory banks. Anybody need help? 20. Okay, on that page, 8 would be a 2-answer question, so 4 real-world points. Likewise, 9 is a 2-answer question, so 4 real-world points. Everything else is a single answer, so 2 real-world points. But 8 and 9 has like a little bit extra to it because there were doubles there. 21 to 33, 21 is a double answer, 22 is a double answer, 23 is a 6 times answer, so that's like a 12-point question, which is a lot. Like usually your homeworks are like 4 or 5 points. So like doing number 23 just took on the value of like 2 homework assignments, so that's pretty wild. 33, we're gonna have 5 answers here, but the test must have 4, because I have this jotted down as a like quadruple answer, but this problem we're about to do is gonna have 5 answers on 33. So like a 10-point real world question. 21 is 150 and then a 315. Brief summary is replace the pi with 180 and just do the math that you see. 22 is 3 pi over 4 and 4 pi over 3. Brief summary would be to multiply the fraction pi over 180 and then go at it. Having chemistry would actually help you here, because you could think about it this way. I'm giving you degrees, so you want to get rid of degrees, and you want to create radians. And we know that 180 degrees
Is 1 pi.
is 1 pi, and you could like do that like chemistry dimensional analysis style if you wish to, but if you don't wish to, that's fine. But whether you're thinking of this or you're just memorizing a detail, that is what you're doing. You're just doing a unit conversion. 23 is using the chart, so whether you're doing the chart radian style or whether you're converting to degrees and doing the chart more old-fashioned trig degree style, that's up to you. If you don't have the chart on your card yet, you probably want to. If you don't have the SACT thing on there yet, you probably want to. Sine is negative root 2 over 2, so is cosine. Tan is 1. Cosecant is negative root 2. Secant is also negative root 2. Cotan is 1. And that's basically the end of chapter 1 of our year. Anything up to 23?
What is negative?
You're in the T quadrant.
How do you decide that you're in the T quadrant?
So I would say change that to 225, might be more comfortable than pi's.
Okay.
Are you okay with 225 being in the T quadrant? Okay.
Yeah, I just should have done that.
If you're thinking about radian mode, the separating line between S and T would be pi. And we're more than a pi, but not by much. So we're still in the T quadrant. If you want to think about the radians themselves, it can be done, but if you're more comfortable in degree land, just switch everything. If you're going to go to college major in engineering, you might want to just get a little bit more comfortable with radians, but you're not doing that, so you're going to be more than fine just at the end of this year flushing all this stuff about all of this calculus business.
I will be doing that.
Lucky.
Then you just have to decide what math you're taking. I would suggest, personal opinion for you would be take college algebra, because
Yeah.
in the process of doing this year, we basically redid algebra 2. Like pretty much everything from algebra 2 came up in this course again.
Not the Z's.
So, no, not the Z's
R.I.P.
and not the I's, I guess. But if you went and did college algebra and you're like factoring and foiling and distributing, and like you'd have it made.
That's an easy 100%.
If they tried to tell you like take some funny elective math that's super easy, I wouldn't buy that. I would just go straight college algebra. Don't outsmart. Like the English kids will be scared of math. Like college algebra would give them nightmares. A lot of them.
Yes,
Don't listen to
that's great.
don't listen to them. Like if you need a math requirement, take whatever math you want to take without fear. But don't get suckered into this is easy math because you'll want to like hit your head off the table.
General math.
general, not college.
They suckered Emily into taking math of money because the people were like all afraid of math in her department. But she hated math of money because it was like she had to memorize all these formulas that she didn't want to memorize for money stuff.
Yeah.
She didn't enjoy it. She'd have been better just taking college algebra. She listened to her advisor,
Do
not her
my
dad.
eyes closed.
24 group. So this is probably hazy. So explanation then answer. 24, when it says F of, you're looking for a filled in dot. If you can't find a filled in dot for the F of questions, you can't do it. Every answer has to do with a y-axis height. All of the numbers I give you have to do with X address, find the right location. So 24, you go -2 on the x-axis and find your filled in dot. That is a height of 6. Let me skip the number 30. If I go to -4 on the x-axis, my filled in dot has a height of 0. 31, if I head toward the y-axis 0 location, I'm going to find a filled in dot at 4. You could argue with me if you wanted to lose an argument that there's not a filled in dot, because there is, because any continuous part of the curve is made up of an infinite amount of drawable dots, just no one chooses to draw that infinite amount of dots. Question about 24, 30, 31? 25 to the rest, you don't care at all about open dots. You're not trying to land on the exact location anymore as we were before. The ones with little minuses, we're trying to come from the left and get really, 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 really close to some sort of anything. It might be a ledge or a precipice of some sort you could fall off, but you're not going to fall off. You're just trying to get really, really close and take a peek. If it has the little plus, you're coming from the right to just take a peek at how high you are. There is a danger. You might be like falling in a hole if you actually got there, but we're not actually trying to get there. We're just trying to get really, really, really close. If I don't put the little minus or plus, you have to consider both of them, and they have to agree. If they disagree, then you Lindsay Lohan Mean Girl style say the limit does not exist. But if they do agree, you go with that number. And that's like the little summary of this. So 25, I'm just coming from the left. That's like the underground road in that little valley. That's a -2 answer. For 26, we're coming from the right, so that's part of that little like mountain hill that's above ground. That has a height of 0. 27, I go two-sided, and since those guys didn't go to the same place, we say the limit does not exist. I used to make this gesture too, yeah, if you want to look at me for a hand gesture. When the two pieces of graph go like this and don't touch, that's a limit does not exist kind of moment if I go two-sided. If I go one-sided, we have those both, but two-sided is a no-go. 28 is another limit does not exist, no answer for the same reason 27 was. At 1, we've got a high road and a low road that don't touch. 29, we're going with 4. 32, we're going with 4. I didn't do it here, so I probably wouldn't on the test. If I go to the very, very, very beginning or the very, very, very end, those only have to be one-sided. So if I were back at -6, I'd go 0. If I were over at positive, whatever this counts to, I'd go -2, because I'd be looking at that like I'm a little spider walking on the graph. I'm headed toward that hole. I don't even know that there's that stray dot that's up in heaven. 33, discontinuous means, in normal people terms, you'd have to lift your pen and put it back down to continue your drawing. In calculus terms, it means either that the function doesn't exist, there's a hole in it, the limit doesn't exist because of that whole high road, low road hand gesture I was just making, or third choice, the limit didn't equal the function for some reason. So you have like a hand gesture agreement here, but like the dot itself is like floating off in space somewhere weird. So 33, you have 4 trouble zones. From left to right, -4 is bad, limit does not exist. -2 is bad, limit does not exist. +1 is bad, limit does not exist. 4 is bad, function does not exist, even though the limit did. And 7 is bad because the limit didn't equal the function, because the stray dot didn't match what was going on. Anybody need to run back through anything to 33s? That was the beginning of chapter 2. Then 34 to 55 is a combination. It's the rest of chapter 2 plus it's all the stuff doing in chapter 6 with L'Hôpital. So here's a summary paragraph that I gave you back when we were in chapter 2. So it's like it's like a rule in 2 parts, but each of the 2 parts has like 3 sub-parts. So here's our 2 categories. If X is approaching a number, first try to plug it in. It may just work. And if it does, great. If it doesn't work, part of that continuation of that rule, if it's a number over 0, maybe the answer is infinity, but you have to be able to decide on the sign. And I used to always say, beware the 2-sided limits, like beware of dog. If you ever see a calculus sign on sale, beware the 2-sided limits. In the beware of dog section, I'll take it. Third choice is it's 0 over 0. If it's 0 over 0, you need a trick or a rule. By trick, I mean things like factor to cancel. By rule, I mean something like the sine of 0 over 0 is guaranteed to make 1. Or by rule, I mean L'Hôpital's rule from chapter 6. And that covers half of these problems. Do you want me to run back that paragraph again? Okay, the other half is if X is approaching infinity. So if X is approaching infinity, it's another 3-part system. You hope probably for the bottom to have the biggest power. 0. Back up, you hope that they tie. Top and bottom have the same biggest power. Then you make a fraction. What you don't want to have happen is the top have the bigger power, because now you got to think a little bit more. It's probably some kind of infinity, but you have to again decide on the sign. And there's like a process to that. And then I'll do a bunch of answers and you can tell me which ones you need an explanation process for. 34 is no answer, beware the 2-sided limit. 14, 5/4, no answer, beware the 2-sided limit. 10, 1/3, 0, 0 again. And I'm up to 42. 5/3, positive infinity, 0, 1, 1/3, 4/5, impossible, beware the 2-sided limit. 0, 4, 51 I did L'Hôpital's rule. You could also separate it into fractions and do the pieces. There's a bunch of ways you could do 51, old skills, new skills, doesn't really matter. But we are hoping for 4. 52, I made a common denominator, got it put together, did L'Hôpital's rule. Twice actually. There's some product rule happening on the bottom. -1 is that answer. 53 is our more modern stuff we've been doing. It's going to resemble a Christmas tree a little bit. It's e to the 2. 54, you could either separate it into fractions and deal with the pieces or do L'Hôpital's rule. It's going to be 4. 55 is a definite L'Hôpital's rule. You are able to decide on the sign. It feels like another beware the 2-sided limit, no answer, but you can actually do it. It is positive infinity, and those don't usually work out, but that one, it did. Are you trying to steal one of my people away?
I just need one of them to give me an email address.
Okay. We're presently recording, so you're gonna be famous. Anybody 55? Need help on that grouping?
Repeats
Okay.
from like 38 down
So-
because I got lost and then it was.
So 38's 10. 39's a third.
Wait, what is 38?
38 is 10.
Okay.
39's 1/3. 2 zeros in a row. 42 was 5/3. Did that help you recalibrate, or is it still off?
It's off until 51.
Okay. 43 is infinity. 44 is 0. 1. 1/3. 4/5. Impossible. 0. And then 4 twice in a row.
Okay.
What can I do to help on those?
$49.
49. So the sign is going to turn everything into a number somewhere between -1 and 1. And the bottom is infinitely sized. So bottom wins for sure, and we can go with 0. Or ridiculous story time, that's like my cookie to China analogy. More? 47. Tan of 0 over 0 by rule is 1. So, also sine of 0 over 0 by rule is 1. So like 45, I do by rule as 1. 46, the numbers mess it up a little bit for 1/3. 47, the numbers mess it up a little bit for 4/5. If you doubt your ability to remember that that's just a rule for sine and tan, you could do L'Hopital's rule. The bottom would turn into 5 and be part of the answer. The top, tan, would turn into stuff with like secant squared
Are we allowed to put that on the card?
things. Yeah, I guess you could put like limit x approaches 0, sine x over x makes 1. Limit x approaches 0, tan x over x makes 1. That's basically a rule or a fact. And the card's pretty much good for any rules or facts. What you couldn't do is write a sentence next to it that says, if there's numbers in the problem, make a fraction out of those numbers. But if you use that as your basis and then you remember what to do with the 3 and 46 and the 4 and the 5 and 47, yeah, I think that's fair.
It equals 1, right?
Yeah, sine of 0 over 0 makes 1, and tan of 0 over 0 makes 1. And if those are upside down, they still make 1.
Yeah. Okay. So not cosine?
No, cosine of 0 is 1. So you don't run into those kind of problems. Cosine doesn't need the same bailouts. Like 0 over 0 caused fights, and that's like what caused the Bernoulli to throw his son out of the house and all those arguments and stuff we read about. But 0 over 0 has been controversial. But since cosine makes 1, cosine's non-controversial.
Who's next in this one?
His son won his math award he wanted, so out he goes. More on that 55er page. So we're close to getting that other page. We'll just break here. You could stop the record, but for the next day, I'd say go front, back, front, back. Let's go front, back, front, back, front, back. Let's do 6 faces, because then front, back, front, back, front. That would leave 5 faces for the last day. I don't know that we'll get all 6 faces next time, but let's try to get up to 91 with like front, back, front, back, front, back. That should be in the ballpark of where it will be. All right, so continuing on with the calculus final into a new portion. 56 would be a 3 answer question, so 6 real world points. I circled that open dot and I wrote discontinuity. I circled a portion where it did go vertical and I wrote vertical tangent. And then I circled that corner, that spiky corner at the top of the one mountain, and I circled that and wrote corner. So I'm fine. If you follow suit, just circle where there's a problem and then have a word or a phrase that describes what the problem was. 57 is 12x squared plus 10x plus 6. 58, I rewrote with negative powers, and then when added, negative 8x to the negative 5th plus 6x to the negative 3rd minus 7x to the negative 2. 59 is a product rule. You could FOIL it, but you'd still have to do the product rule. So I don't see an advantage there to foiling it. I think I would just live with the product rule. It's negative 6x sine x minus 8x, or minus 8 sine x plus 6 cosine x plus 18. Double check your signs. Minus on the 6 with the sine, minus on the 8 with the sine, plus on the 6 with the cosine, plus 18. 60, quotient rule, no real way around it. The top is 12x squared minus 8x minus 5. The bottom is the original bottom, but in parentheses, now getting squared. 61, I just lived with the quotient rule. You could rewrite that as a multiplication problem with x to the negative 1 and then do a product rule, but I don't see that as a big gain of time. I just lived with the quotient rule because there's none of the derivatives are that big for the quotient rule approach. It's going to be, if you do the quotient rule approach, x secant x tan x minus secant x all on the top and x squared on the bottom. 62, I did trig tricks. Final answer ends up being 0. Trig trick, then derivative. 63, I did product rule. I think it's unavoidable. It's negative sine squared x plus cosine squared x. There is trig that could simplify that, but it's not worth it. 64 starts the chain rule, so make sure you work from the outside in and don't forget a piece. So what I had on 64 was an 8 that's a solo artist, a set of parentheses with 6x plus 6, and then another set of parentheses that's the original set of parentheses but with a 7th power. 65, also the chain rule, I have 9 that happened because of 3 times 3 occurring. 9 sine squared, same parentheses as the problem. Also cosine, same parentheses as the problem. The trig arguments, as you do derivatives, never change. So if you have trig parentheses in the problem, you're going to get trig parentheses in the answer. And if you have a couple trig words in the answer, you have the same parentheses a couple times. Similarly on 66, we're going to go 4 as a solo artist out into the front. 1 set of parentheses with 18x to the 5th plus 8. If you really want to distribute everything I said so far, go ahead. If you really wanted to distribute on 64, go ahead. But make sure the stuff that you get for the answer is still in its own set of parentheses. 66, after what I said already, then there's tan to the 3rd power with the same parentheses as the problem, and there's a secant squared with the same parentheses as the problem. Can I do anything to educate you?
So you keep the original trig word and drop power, like for part of it, and then also.
Which one are you looking at?
Those last two.
Okay, so I'd go power. Power is the outermost, although it's written deceptively.
So it goes to the front, yeah.
So power goes to the front. The trig word you have to a power goes down by 1 power, but the parentheses are still there.
Okay.
And then you have to do the derivative of that trig word, which is going to be another trig word,
Right.
or even 2 more trig words.
And
then the parentheses, though, are still there.
Okay, yeah.
More to 66.
60?
60. So copy the bottom in parentheses, 3x minus 1.
Yeah.
Foil that out with, in parentheses, the derivative of the top, 8x plus 5. Minus. Copy the top in parentheses, and then distribute a 3.
Okay.
Do all that algebra, and you should get the top that I said.
Okay.
Is that new ground?
I just didn't, like, what's it called? Factor?
Foil?
Foil, yeah.
Did you have 3x minus 1, or did you have 8x plus 5?
Yeah.
Okay. Do you want me to tell you what that became?
Yeah.
I had a 24x squared minus an 8x plus a 15x that maybe you combined in your head as you did it to get a plus 7x, I don't know,
Yeah.
minus a 5. Then the back half, sometimes the negative, the minus sign for the quotient rule, like fusses with people. That minus is going to switch signs of everybody
Yeah.
at the tail end to get a minus 12x squared and a minus 15x.
Yeah.
Then if you put that together, 12x squared is from combining, a minus 8x is from combining, and the minus 5 is there because it never had any friends.
So
12x squared minus 8x minus 5.
minus.
Because the minus 5's been there for a while.
Yeah.
More? Anything? 67 is a thing called implicit differentiation, which means everywhere you do a derivative of a y, you leave this symbol. And then that symbol gets algebra isolated by doing opposites. If you had a couple of those symbols, you'd have to collect them to a side and do some factoring of a GCF, but that didn't happen on these two problems, but that used to happen. 67, if you do it right, it's 2x plus cosine x on top, 3 on the bottom. 68 would be a negative x on the top, y on the bottom. 69 relies on 68 being right, and then you doing the quotient rule. And it also involves you replacing a new y prime you'll create with the answer you just made in 68 and doing some math. I'll read answer and then we can double back. That might be a board-worthy question. Let's see. The total answer is negative 1 on top of y minus x squared over y cubed. 70 I do as a 4 answer, so 8 point kind of question. Even though this isn't hard, there's a lot of answers here. It's 24x to the third plus 9x squared plus 12x plus 5. Then 72x squared plus 18x plus 12. Then 144x plus 18. Then 144. Then a 0. And then we stop. We do want 0 in our list. 71 group, it's on this page where I've organized all the derivatives into a cluster, but this is from a couple days ago. Like, this is the test that you just took now on most of these questions. 71 is 4 on top of x. 72 is negative 15x to the fourth e to the same power. 73 is 4 to the x ln 4. 74 gets a negative because one of the trig derivatives did that. So some order of negative 2 sine 2x ln 3, 3 to the same power, that's all there. 75 is 2 on top, the bottom has x ln 4. 76 has the original stuff, and then in parentheses 3 fractions. The first one simplifies. 3x plus 12 on top, x squared plus 6x on the bottom, plus a middle fraction is 5x to the fourth plus 3 over the x to the fifth plus 3x that we've had. Then a minus, a 2x plus 6 on top of the x squared plus 6x that we had. And then what can I do for you with my mind wandering
68.
heavily if you want to talk about a couple of the 68 leading into 69. So 68, we go 2x plus 2y, leave a y prime there, equals, and then it's a 0. Sometimes people keep the 10 in that list, like Rex the thing, but derivative of 10 will be a 0. You with that?
Yeah.
Then you want to get the y prime alone, so we'd subtract the xy stuff out of there, divide by the yz stuff,
Which is just.
cancel some 2's, negative x over y.
Yeah.
Then keep going into 69.
Yeah.
Okay. So for that one, we need to now do quotient rule. So we're going to go bottom
So y.
times derivative of top minus top derivative of bottom, temporarily there, all over bottom get squared.
Yeah.
Okay? You can have a mix of x's and y's, that's not a problem. But what we can't have is y prime take up permanent residence in any of these answers. So we can replace y prime by just looking up about an inch to the previous question, and we said that that was negative x on top of y. So we'll make that swap in. You with that swap in?
Yeah.
Then treat this like it's two different fractions. If we act like that's a fraction, the y's cancel to leave a stray y on the bottom, So -1 on top, y on the bottom,
Yeah.
out of the stuff you can see.
Okay.
Then when we
And
step
then-
over here, negative, 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 triple negative makes it negative. X and X are both above ground everything, so X squared's gonna be a top kind of thing. And then these Y's are both like nested underneath as divisions.
Yeah.
So that's a Y to the third that goes under.
Okay.
More through 76.
One more time, what is the final answer on that one?
-1 on top of Y minus X squared on top of Y cubed. Any more? 77 is like sort of a mini page because I just don't think I wanted to continue off the topic of derivatives, and then I had a weird problem to go next and I just saved that for the next page. 77 is the easiest one of this page probably. 12x on the top, and then the bottom has a root 1 minus 36x to the 4th. 78 is a little harder because you either have a negative power that you have to like negotiate out of the final answer, or if you flip it into a cotan problem, then you have a fraction to negotiate out of the final answer. They both work, you just have to decide which like algebra technique you're better at as an individual person. Final answer is going to have a negative. It's going to be 12x squared on top. It's going to be 16 plus x to the 6th on the bottom. 79 might be the easiest one. If 77 isn't the easiest one, 79 is, because it's easy to do derivatives of 6x squared on 77, and it's easy to do e derivatives on 79. 79 grand total after a little bit of canceling is going to be a 3 on the top and then a root on the bottom, which is e to the 6x minus 1. 80 makes no sense, I don't think, to flip. I think that just makes it worse. I think you just have to deal with fractions and fractions and how to manage that tactic. Final answer is a negative, a 1 on the top. Bottom has a root 25 minus x squared. And then do you need anything?
Can you repeat that answer?
-1 over a root of 25 minus x squared. Those were never your favorite problems, but those should be still pretty good. I mean, we just did that. Reminder as midterm approaches next Friday that fixing a 6, 5 through 9 quiz is a thing that I have nobody's papers yet, so that could be a thing to do. Anything to 80. Then we have some flashbacks. So these next 2, 3, 4, however many pages, about 4 pages, front, back, front, back. These next bunch of pages are based on mostly the idea of doing derivatives. Like derivatives are still running the show, but it was doing derivatives to perform other tasks. So this is probably some of the harder parts of this test. As we talked about in chem recently, the human memory tends to remember beginnings, ends, and forgets the middles, and these are middles. There's also, these are tactics that we haven't used for a while. It's not like the stuff we just got done doing. We've been doing the product of quotient rules, so that's not a difficult adjustment, but we haven't thrown a rock in the air on a calculus test for quite a few months.
No, he wasn't good at this.
81, velocity is just a derivative, so 40 minus 6.4t. Acceleration's the derivative of that, which is negative 6.4. The third question, you have to remember what maximum height means is happening in physics. What happens at maximum height? Velocity equals 0. So we have to use the velocity equation we made in conjunction with 0, do a little bit of algebra, we're hoping for 6.25. If you don't achieve the 6.25, you will not score again. If you do achieve the 6.25, you keep yourself alive. How high? How high is which of these equations now? Which one? The distance. The S original equation is now what we're using for maximum height, and we're using the 6.25 for the time to get math happening, and that's 125. The how long the rock is aloft is a very easy question if you got the 6.25 right.
It's 12.5.
It's 12.5, you just double it. What goes up must come down. Physics and gravity and God and Newton and all of those people have combined to give us some symmetry there, so we just double that, and that's a nice easy fix. If you didn't get the 125 right, you can't get this last question right. What we're going to have to do is take half of the 125 to get 62.5 and stick it where?
The S.
To the S. So 62.5 equals that top line. Let your quadratic do what it does. You'll get two answers, one that's on the way up, the other on the way down. Symmetry will help us be able to check that. I'm hoping for 1.83 and 10.67. And if you want a checker, add those together, and that should correspond exactly to the 12.5 we just discussed like 60 seconds ago. Those last answer, those two, should add up to the how long the rock is aloft every time. That would be a 6 answer, therefore 12-point question.
So, which number is the A for the quadratic?
The one with the square. So negative 3.2. Unless you got everything isolated to the other side, in which case it's a positive 3.2. But the A is something to do with
Is it
3.2.
like a 1.8 to 10.6?
1.83, 10.67, yeah. Anything else 81 based?
The max height again, how do you get that?
We're gonna go, that mean, did you get the 6.25?
Yes.
So how high is S? So you go to the S equation to get the S, knowing 6.25 is the T.
Okay.
How fast is always V. How high or where, that's always S.
Okay.
How long, that's a time. That could come from anywhere. More, 81s?
What was the answer?
What was
375?
125?
125.
How high maximum height? It's 125. 40 times 6.25
Yeah.
minus 3.2 times 6.25 squared.
Wait. Yeah, okay. I got it.
Anything more before I jump to 82? Okay, 82 is a 10 answer, therefore 20-point question. Just trying to interpret this crazy old graph. So I graphed your velocity. There's a V on my graph. If you want speed, that's a near synonym. What's the only difference with speed? We flip the negative stuff to become positive stuff. So right in the middle from 3 to 6, we had a valley on my original graph. We just have to fold that up into a symmetric mountain, just mirrored above ground instead of underground. Acceleration is the annoying answer because you have to compute a whole bunch of slopes. So it's nice when we go like this because this has a slope of 0. If it goes like this, generally it has a slope that's some kind of a positive. This is a slope that's some kind of a negative. It just depends on how much. So we're doing like a rise over run, change in y over change in x kind of thing using our eyeballs here for a little bit. So 0 to 1, the slope is 0. So we're going to draw just a little step on the x-axis. From 1 to 2, we go uphill, so that's positive how much? Try again, 4. Because it went up 4 units, while it went across only 1 unit. So the height change is 4, the sideways change was 1, so that's a slope of 4. So 1 to 2, we get a step that lines up at a height with 4. 2 to 4 is a negative slope. You can do that whole zone because it stayed like nice and straight and flat. So from 2 to 4,
-8.
-8 is correct. So from 2 to 4, our step lines up with -8. 4 to 5, easy. 0 on the x-axis for that step. From 5 to 7, we're nice straight uphill.
Positive
That is +8. 7 to 8 is another downhill. It's -8. And from 8 to 10,
0.
0 back on the x-axis. Speed up, I think, is easiest answered by looking at the speed graph, which is your slightly modified graph, where you mirrored me. I think to do speed up, you're easiest to look at the speed graph going up. If you want to look at my original graph, you could look at my original graph and have it be going away from rest, where rest is represented by the x-axis. So either away from rest on my original or up on the one you modified. So where are some zones that do that?
1 to 2.
Yep. Yep. One more.
6 is
Yep. Slow down, I would do the opposite. Either look at the speed graph you modified going down, or look at my original graph going toward rest, toward the x-axis.
2 to 3.
2 to 3,
5 to 6.
5 to 6,
7 to 8.
all true. Constant speed, I'd look for where it's neither speeding up nor slowing down, aka anywhere that it's flatlined.
0 to 1.
Yep. Yep.
8 to 10.
Yep. Moving forward means that the velocity, my original velocity, is positive. So everything that's above the x-axis.
0 to 3.
And
6 to 8.
agreed. Moving backward is therefore everything below. Everything that you folded previously to do the mirror symmetry mountain match. 3 to 6. Stand still is therefore what's left, where it's 8 to 10 on the axis. You could also argue for 3 instantly and 6 instantly. And I didn't care about that on my answers. So if you put them, great. If you didn't put them, great. It's instantaneously happening. So like, my opinion on that is, hey, whatever. Change of direction,
3 and
that's
6.
the 3 and the 6 for sure. No debate about that. Maximum speed, since it said speed, I would look at the speed graph for where it went highest. Or if you want to look at my velocity graph, you could, but you'd have to consider both extremes, highest and lowest, being competitively at the same time at each other.
2.
2 is a moment.
4.
4 through 5 is a session, and 7 is another moment. So 2, 7, and 4 to 5.
Wouldn't it though just be 4 because you say reach max speed? Because you're already at max speed at 5.
You could argue that, but I'd rather get the whole zone.
Okay.
I could see that argument. More through to 82. So we'll do another face today and then finish the rest another time. So this 83 page, derivatives still continue to rule the day. It's just a question of how we're using them and also what punctuation we're using. So differentials, there's 3 ways that we can use derivative punctuation. That means we did a derivative, we already used that. This means we did a derivative. This means we did a derivative. So we're not going to use this again. This is more like this. This is more like this in history and meaning and where it came from. This is us finding the slope. Slope is a measurement of our word, rates, speeds, things like that. This is just an amount of change. And that's what the differentials measure. Differentials measure amounts of change. So we're looking to go with just a D on this next problem. We're looking at just a D on 84, because 83 and 84, differentials and changes are that. When we go to 86, where, you know, I should have probably explicitly used the word rate, but I did use the word derivatives, which are rates. 86, I'm looking more to express it this way with the symbols that we're using. The other problems, it doesn't matter which symbols you're using, but this page, it is about knowing which symbol like goes with which thing. So 83, I'm going to go dv equals 4 pi r squared dr. 84 is a 2-point question because you have to do that, and then you have to plug some numbers in. The final answer will be 0.24 pi. If you don't know formulas and you were looking them up on this review, make sure your card has things like volume formulas for spheres, surface area spheres, circumference areas for circles, you know, whatever formulas you might think could be on there. Pretty much spheres and circles have ruled the day, I would say, over our year. 85, there's like a whole process to do it. This is the one that involved you spamming the enter button once you got a computation set up. 85, before you start, you should do what? Before you do even any calculus. Let's try this. X cubed could have how many answers? Could have 3. But it also could have 2,
Or
1, or no. How do you know before you start?
Synthetic division.
No. We could do that if we want to dip into our algebra tricks, but there's a quicker way to know whether there's 3, 2, 1, or 0 answers before you even get the game on. You wouldn't have wanted to do this in Algebra 2 because you didn't have the tool for it. No. Quadratic only works for x squared stuff. You all have one right now on your desk or in your backpack.
Oh, do you?
I can see a few of them.
Oh, graph it?
Yeah, graph it. So what about the graph tells you how many answers there are?
How many times it touches the axis?
How many times it touches the x-axis. So if it touches the x-axis 3 times, you're on a triple hunt. If it touches twice, you're on a double hunt. Touches once, you're on a single hunt. And the other thing you have to do to start the hunt, you have to guess. And if you graph it, it gives you a pretty good guess. Because let's say your graph goes like this. And this you can tell is like around 1.5. If you guess 1.5-ish, it's going to find that pretty fast. But if you guess like -20, -20 will never find this.
Because
-20 will find this one. And then if you try to guess -15, it's going to keep finding that one. And you guess -10, it's going to keep finding that one. You're only going to find this one if you guess something like
-1.
-1. You're only going to find this one if you guess something like 3. You have to guess something that's in its neighborhood to find it. So if you graph, it's going to give you a lot of valuable information, but most importantly is probably how many answers there's going to be. Second most importantly is just what neighborhood it's in to make your guess. 85 happens to only have one answer, but this is a 3 answer, therefore 6-point question on the test. So I'm guessing the test might have 3 answers. So if you don't remember how to like keep getting more answers, I can get that back. But this one's going to give you 2 point. 310852163. This is the one where we would like just hit the enter button. When would we stop?
Whenever it was like stop.
Whenever it
Changing.
stopped changing. As soon as it started repeating itself, we knew we were as good as the calculator could get us. 86, I wrote DADT. When I say DADT, I mean it looks like DA on top of DT. DADT equals 8 pi R dRdt. 87, you'd have to write an equation, which is the Pythagorean theorem, do some derivatives, plug some stuff into it. We're hoping for an answer on this of 8. And then I'm not sure what more details you're going to need beyond what I just said.
85.
85. So we're going to go, did you graph it?
Yeah.
Can you see how it's like in the neighborhood of like 2 or 3 or something?
Yeah.
Okay, so what you would do on your calculator is punch 2 or 3 or something in that neighborhood and just hit enter. And that seems foolish, but we just need to do that to get the calculator what is in our brain.
Okay.
Then we're going to go answer button minus parentheses the original formula. So in parentheses, answer to the 3rd power minus answer squared minus 7.
Okay.
Wrap those parentheses. Divided by new set of parentheses, which would have what in them? The derivative. So
Wait,
the derivative would
answer, like the problem.
be the problem itself,
Yeah.
but instead of X's, you're using
Yeah.
answer buttons. And then that's all in parentheses divided by new set of parentheses, the derivatives formula, but not using X, using the answer button.
Okay.
And the derivative would be
3x squared.
yeah,
minus
3 stuff squared
2
minus
x.
2 stuff. But instead of, stuff, use the answer button. Wrap that parentheses. When you hit enter, it should get closer to 2.31 than you were.
Yeah.
And
okay.
again and again and again and again and again and again and again. If it bounces all over the place, you probably wrote the formula upside down. Like, if you don't remember to put original over derivative, but instead you put derivative over original, then I think it's gonna it's gonna bounce all over creation. I don't think it would ever repeat for you. I think it would do something weird. And as always, if you want to know if you're right, anytime you solved any equation in any subject, starting in like 7th grade pre-algebra stuff you did, just plug it in and check it. So if you do 2.31 cubed minus 2.31 squared minus 7, it is more or less 0 minus the little bit of rounding error.
Is that answer minus original over derivative? Is
It-
that legal quote unquote?
Yeah. You could go Newton's method, answer minus original over derivative, sure. If we had to do another one, what we would do then is, like if we saw there was an answer down here near like 5, you'd go 5, hit enter, and then you'd use the second entry to get that massive formula with all the parentheses and answer buttons back, and then you just re-spam the answer key. Then you do another number. Do the same thing. You could do that as many times as you needed to do it, but if you don't graph, you have no idea how many answers you're hunting or where they might even be.
What was the last one?
Last one, we're hoping for 8.
Okay.
You need a little guidance there.
Yeah.
So do you have a Pythagorean theorem?
No.
Okay, we'll start with that and then maybe we talk next time.
Because the 5 is at the bottom.
5's the hypotenuse.
5's.
Because
Oh,
the
wait,
ladder's
yeah.
5. And the ladder's not a variable, the ladder is 5.
Yeah.
The legs are variables. one of which you do know the number for it at this moment in time.
4.
It is, and then the other one you can figure out the number for it at this moment in time. And it's 3. We know this. Then like that's what the XYZ stuff. The XY, if you're using XYZ as your letters or XY as your letters, you know 3, you know 4. But when you do the derivative, there's also going to be like a dxdt and a dydt. Those are the speeds. Those are the rates. That's the 6 feet per second is one of them, and then you're hunting the other one.
Okay.
And if it's decreasing, it's a negative rate. If it's increasing, it's a positive rate. So if we're sliding toward the wall, go negative. If we're sliding down, go negative. But if we're like rising away from the ground or sliding away from the wall, you've got to go positive on the rates.
Okay.
Is that enough to get you going?
I think so.
So chapter 11, off we go. So they say in the notes that this was a transitional chapter.
That's
So-
Haven't they said that about every chapter?
Yes.
I was just baiting you into rage commentary. I was thinking someone was going to say it's a transitional book. So they are headed from Pamplona, where they were, out to a place called Burget, because they're going to escape and go fishing. So weather was super hot at first when they get on the bus there in town. Cone temporarily saved a seat for Jake to go get some wine. Cone, who's an outsider, he doesn't drink, is a side note made by some website somewhere. 3, then back to 2. 3, they have all these leather wine bottles. It's like everybody has them, everybody wants them. If you want to be in the in crowd, you've got to drink out of a leather wine bottle. All these people headed to Basque country, that's just how they drink their wine. So they get an education in how to drink out of a leather wine bottle. Fake sound somebody was making was a klaxon horn, which, according to my curiosity, when I looked that up once upon a time, goes something like Ayuga, Ayuga. One of those old time kind of horns. That's a klaxon horn. So there's some sort of human making fake horn sounds. I'm sure that would get old fast. Once they start moving, the breeze cools them down a little bit. They make one stop in one town. It thinned out the crowd a little bit on their transportation. We meet a man who had been to America, and he had a side conversation here with Hemingway for a while. So something there. He was there 15 years. He came back to get married. Chicago, St. Louis, Kansas City, Denver, LA, Salt Lake City all make the conversation. Other stuff that I didn't write down. Once they're up in the mountains, unsurprisingly, if you have any experience or knowledge about that sort of lifestyle, it gets cold up there. You go up the mountains, it gets cold. Hot at the bottom, cold at the top. Extra credit, there was a monastery that was called Roncesvalles, Roncesvalls, or maybe Roncevaux, Roncevaux. That first one I pronounced more like an American would. The second one is that, like French would say, Roncesvalles and Roncevaux. They could see their breath, actually. When they got to the inn at the end, they could see their breath. So they get there, we're passing time. Bill played the piano just to do something. They sort of get ripped off for the room, but not really. So they thought the price was too high. They ultimately agree to pay the price because they're told by the person at the desk that it's the busy season. So they're like, oh, it's the busy season? All right, well, we'll pay for that. There's another reason they agreed to pay too that you could use. Was it really the busy season there? No. Who was there? Who was there?
I don't know.
Just those two.
Yeah.
It's them, like in an empty hotel. So they're told at the desk, it's the busy season, you got to pay more. They also negotiated that wine would be included in the price, and they accepted that deal. So I think the desk keeper agreed I think the desk keeper is thinking that he ripped them off and conned them and got a pretty good deal. But this book, these characters, if it's drink all you can,
They're gonna drink all they can.
yeah, they might have shut that joint down. Like that place might not have survived the week if you're supplying these characters with all the alcohol they can drink included in their price. I don't think they did well on that negotiation. They should have charged them the 10 pesetas and charged them for their wine. They'd have done a lot better. But 7, you could use either busy season or wine is included. And then they just kind of like killed time. There was some reading, there was some smoke, and that's like what was going on there. Jake continues to pay for things, which paying for things continues to be apparently one of the themes of the book. But of all the chapters of not much happening, that was probably one of the ones where we got the least amount of stuff happening. I think take the 8, throw just a +2 on there to make a score that would be a 10 with a bonus. You could have got to 11 as always. Questions, comments, 11s? That on down. So I think we left off needing to start with 88. Is that where we are?
I believe so.
Okay, so 88, you need a circumference formula, which you don't know maybe. If you don't know that, throw that on your card. Answer I'm hunting is a 0.8 pi. So that would be a two question kind of thing of like a point for knowing the formula and doing the derivative, and then another point for plugging in the right stuff. 89, the gist here is you do the derivative, you factor, and that gives you up 2 numbers. Anybody with confidence in the 2 numbers that factoring gives you up?
So -4, -2.
Agreed. You make sure those numbers are in bounds, which they are, because the boundary is from -5 to 5. So we take then 4 numbers and plug it into the original problem. -5, -4, -2, +5, all plugged into the original, and then you look for highest and lowest results. 5 gives you the max of 470, and preferably write that like an ordered pair, like x of 5, y of 470 is the max. The min is interesting if you did it right. What happened to the min? Anybody get an interesting min circumstance? Say again? It's a tie. -5 gets you -20, and -2 gets you -20, and that's a tie for min. I did that as a 3 question 6-point kind of zone there. 20, same style. I did it as like a 3 question 6-point kind of layer. So critical points you get from the parentheses, but you want to do them in number line order. So -4 first, -2 in the middle, +3 on the right. Then you plug in numbers from your imagination in the gaps there into the parentheses that I factored for you. So to the left of -4, you're decreasing. In between -4 and -2, you're increasing. Then you decrease, then you increase. You might remember that those usually did alternate like that. Not always, but usually. And then you think about, maybe with hand gestures, if you decreased and then you increased, that would be a min. So -4 is a min. -2 is the opposite, so that's a max. 3 is the same thing again, so that's a min again. 91 is about the same thing. You just have to derivative and factor yourself. So if you derivative and if you factor, you get 3 numbers. How's that going to go? 3 numbers, anybody?
You get like an x outside.
Yeah.
So make a 0.
Yeah, 0.
And then it's like x squared minus 3x minus 10.
True.
This would be a negative, or it'd be a +5 and -2.
+5, -2, yes. And then make sure you go in number line order. So from left to right, -2, 0, 5. It's going to follow the exact same pattern that 90 did. Decrease, increase, decrease, increase. Therefore, min, max, min. Just you can get the y coordinates on 91. So -2, -8 in parentheses is an ordered pair is the first location. The origin is the middle, and then 5, decimal negative 93.75. Or if you like fractions, fractions can win too.
What was the -2 number?
Negative 8. That's from like early chapter 4 is where we are on that. Anything 91?
How do we get the y?
Plug into the original.
Okay.
More. '92 adds another layer to it, so I made this like a 5 answer, therefore 10-point question. So you do the derivative and you factor, and that should give you 2 magic numbers called critical points. Anybody?
0 and 3.
Agreed. You do the derivative again, you factor again, and you get 2 points, one of which is the same, one of which is different. They're called inflection points. Anybody there? It is 0 and 2. You list them all side by side in number line order, so 0 is first, 2 is second, 3 is third. To get the y's for those, you plug into the original. 0, 0 is a point. 2, 16 is a point. 3, 27 is a point. Then to decide increase or decrease, you plug into the derivative. It's easier to plug into the parentheses version, I think. What you're doing there is using your imagination to come up with numbers and just deciding on signs. So left of 0 is an increase. In between 0 and 2 is another increase. Between 2 and 3 is another increase. And then beyond 3 is a decrease. Those don't usually alternate because 2 wasn't even trying to play that game there. Between 0 and 3, that double gap had to be the same answer because 2 wasn't part of that game. Then you decide concave up or down by plugging into the second derivative. Easiest place is the one with the parentheses. These usually also don't alternate because these numbers don't play all the games. But left of 0 is a down. In between 0 and 2 is an up. Beyond 2, it's down twice. And then we try to make a little shape. The first group I said was increase down. So is this up or down? Down. Which half is this? So I want that. So this is increase down. That's my first little shape. So on the graph, you're going to draw this kind of a shape headed into the origin. Then increase up. Well, I need to switch. So up is this kind of thing. Which of these is the increase half of up?
Your left hand.
My left hand. So we're going to go this shape coming out of the origin to connect to 216. Increase down is a repeat of this shape. So from 2 to 3, we're going to connect with this kind of shape. And then decrease down would
Your left hand.
be my other half of that, like, transition. This looks like a thumbs up if I oriented my thumb this way, in my opinion. 43, we're going to do an antiderivative, temporarily fill in a plus c, but solve that mystery. Then do the antiderivative again, fill in a new plus c, and solve that mystery. And I was really kind to you here by giving you a 0 to plug in for x, because that like unveils the c's with much less work. Total answer is 2/3 x cubed plus 3/2 x squared plus 3x plus 2. Stuff there. What?
How do you get C?
So, by plugging in, like, when you do the antiderivative, you'd have dy dx equals,
Oh,
and you'd make a thing,
yeah.
and then replace everybody with a number. That's enough? Okay. More to 93. 94, we're hoping for a bunch of answers that are similar, but there's like a little bit of difference from some to the others, although two of them do perfectly match. The directly answer is 170 and 2/3, or 170 point repeat 6, or 512/3, however you write that. The rectangle's answer is 168. The trapezoid rule, maybe you want to throw that on your card. It's like h/2, blah, 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 a bunch of stuff. That's 176. Simpsons rule, maybe you want to throw on your card. That's h/3, and then a bunch of stuff. Is that about where we started to use the card, maybe?
Yeah.
So that might already be on the card, those rules. 95 is like a easier section, hopefully, just doing integrals. That's a little bit more, I don't know, it's easier, but it's fresher for sure. I mean, we've been doing this pretty recently. So I got for 95, 3/2 x squared plus 4x plus c, and I'm going to quit saying plus c for the next like 30 straight answers or whatever it'll be. 2/3 x to the 3/2, negative x to the negative 3 plus 5/2 x to the 2. 98, I would suggest separating it into pieces and simplifying the pieces. It's 1/4 x to the 4 plus 1/3 x to the 3. 99 is 1/3 in front and then sine 3x. 100 is x to the 4 plus 3x to the 5/3. 101, you could either do a substitution, or in this case, you could bail yourself out by distributing the x. But since you have two things there, the parentheses are a thing, the x is a thing, you've got some multiplying things. You either have to do a pick a u kind of substitution, or distribute it and take away that like problem. If you did the pick a u scheme, you'd have 1/24, and then the parentheses would be squared. If you did a distributing side step, you'd have 3/2 x to the 4 plus 4x squared. Stuff there.
94,
Mm-hmm. Which part?
like all of it.
So directly means just do the antiderivative and plug it.
Okay.
Rectangles evaluated at the midpoints, you're going to have to think for a little bit about where this would be cut and what the midpoints even are. So if we cut this into 4 chunks, where would the midpoints fall?
2, 4, 6, 8.
No, that's where the cuts would be cut.
Oh, so it'd be 1, 3, 5, 7.
Agreed. So 1, 3, 5, 7 have to get plugged into the formula. In this case, it's x squared, but on a test, it might be a whole different formula. But 1, 3, 5, 7 get plugged into that formula. Add them all up. And then multiply by something. Anybody a theory what we're multiplying by? Not 4.
2?
2. Why 2?
Because that's how far apart they are.
That's how wide you'd have 4 rectangles there. Each one would be 2 wide. You with those first 2?
Yeah.
Trapezoid rule, it's like, you'd have to just look it up at the card. It's like h over whatever. You single count the first and last, but you have to change the ones in the middle.
Yeah, I know which thing you're talking about.
And what you're doing there is the 0, 2, 4, 6, 8 numbers we already decided on. Those are getting plugged into the formula.
Okay.
So 0, 2, 4, 6, 8 get plugged into the formula. You get the results. Some of them need tweaked. You add them all up. And out in front of that, there's like h over something kind of
What is
fraction.
the h?
H is how wide each piece is.
So it'd be
2
so in this case, it would just be you wouldn't do anything because it's 2 over 2.
Correct.
Okay.
But for the Simpsons rule, using that like second entry button is very helpful. Simpsons rule is h over 3. You again count the first and last singles, but in the middle there's like a different way that they get
Yeah.
tweaked. Simpson tweaks them differently than Trapezoid did. That enough to get you on a track?
Yeah.
Anybody else to 101 page?
95.
So rewrite that as x to the anybody?
Wait.
96,
95?
95, I'm sorry. 95, you just do it. It's a 3x to the 1, so powers go up by 1. And you divide in front by the new powers when you're doing these antiderivatives.
So what is it?
3 halves x squared plus 4x.
Oh, so it's just,
It's the antiderivative.
okay.
Like, did you get 100?
Hmm?
Did you get number 100? Right?
No, because I thought this was like, integrating I thought was like to pick the U and like do
No,
some-
integrate is just means antiderivative. It
Okay.
could be pick a u, but it.
Okay, then.
More stuff to 101. 102 to 112. It's a variety of things here. Some of these are just use the card. Some of them are pick a U. But when you use the card, they are still like pick a U. A lot of times on the card, it's like pick a U, pick an A, pick a whatever. You in or out on this page?
There's a few that I have that I'm off on, but I did most of it.
How are you down there? You in or out on these? So 102, we're hoping for 124th. Well, let me. Where can I see your paper? Like, how far are you?
I don't have 106, 108, and 110.
I just didn't have 2, 3, and 4.
So 102, we got to pick a U. Answer here will be 124th. Sign is to the 8th with the same parenthesis. 103 is 1/12 out in the front. I have 4x squared plus 7 in parentheses, so 3 halves. 104 is 1/12, and then in parentheses the 4x cubed thing is the 6th. Those are all pick a U, pick a U, pick a U, find a DU, make some like modifications. 105 just straight off the card. It's 1/3 ln in bars, secant 3x, or there's a negative alternative version with cosine. 106, pretty much straight off the card, like what we were doing last chapter.
Oh.
It's 4 to the power on top, 5 ln 4 on the bottom. 107, it's pretty much off the card. You'd have to recognize it as being an ln problem from your card. Like at the beginning of chapter 6, we did a bunch of these recently. It's 1/12 ln and then in bars the bottom. 108 is just off the card, e to a power, just you tweak the number in front. It's 1/6 e to the same power. 109 is inverse tan problem. 1 on top of 5 root 3 in front, inverse tan 5x over root 3. 110 you have to factor by completing the square, and then it's an inverse tan problem. Inverse tan, and then in parentheses x plus 3. 111 is an inverse secant problem. It needs a little bit of tweaking to make it fit the exact pattern that the card makes us put. But it's 1/20th inverse secant, 4x over 5. Get bars at least around the x. 112 is an inverse sine. It's a half inverse sine, and it's x squared over 4. If there's a mistake, it's usually the number in front, and it's usually because you just didn't check the du and like make it be there.
What do you pick for the U on 1 and
The parentheses.
2? Just the parentheses?
No, sine. I'd pick sine. Yeah, I'd take that back.
Like
So,
sine parentheses.
like-
So
Normal
u would be
sine.
sine parentheses.
Okay. And then.
So then du would be most of the rest of the problem. would the DU have a number?
Yes.
Yes. It would have a
3.
3. So the answer is going to have a 1/3 in play. But when the u to the 7th, like when you antiderivative u to the 7th, that changes the stuff to the 8th and it brings a more fraction into play. More to 1/12.
You go through 107.
There's 7. So you'd have to recognize that on your card, you should have a formula that says integral du on top of u makes ln of bars of bottom. You with that recognition? So what we have to check before we pull the trigger on that is do the derivative of the bottom. The derivative of the bottom is not quite the top, but it's pretty close. What would you want to have on the top? Anybody? 107, derivative of the bottom? We want a 48, not the 4. So the top had to multiply by 12, therefore the answer requires a payment of 1/12.
Okay.
So it was 1 to 1/4 sine 2.
And then the same parentheses. Yep. Yeah, whether you're doing derivatives or integrals, the trig parentheses will always just live on, untouched. More to 112. One 13, 14, 15. I did those as 2 answers apiece, so 4 points apiece questions, because you have to do the antiderivative, which is worth a point to me, and then you plug the numbers in, and the math gets you that secondary point. 113 should total to be 30. 114 is 312. 115 is 6. 116 is the group where you've traditionally been pretty strong. It's going to go 5, 5, 3 ln x, negative 8 ln x to a power of negative 1/12, 2 to a power of 17/12, 2. 123, you could argue whether negative ln sine x is better or positive ln cosecant x is better. And I might say tie. Those are about the same. It just might depend with how you approached that, where you kind of like got satisfied by what you were doing. 124 is 5, and then the last one is 14 ln x. Stuff to clean. 126, poor Calvin. I guess it was destined to happen. You spend too much time around flagpoles, and sooner or later something's gonna go wrong. So Calvin has met his maker. If you carbon date him, we've got Calvin at roughly 82.65 years ago. World War I era, Calvin. Poor guy. Poor guy.
Must have got hit by the flagpole.
It's a tough way to go. Yeah, I'm not sure. Maybe lightning. Could have been a lightning issue. Could have been a toppling over. Maybe he tried to climb it. He wasn't that athletic. I don't know. It's a lot of things could go down. 127. I got an 18.12 and a 75,295. And then even though the test kept going, we stopped there. So tomorrow we kick it in. I think you're going to do better by trying to basically go through it in order. If you skip around, you're going to end up on the last day with like a lot of weird stray problems everywhere and feeling yourself a little bit mad. But If you have to skip something on the first page, I would try to remedy that like on the next day. If you skip something on the second day, I'd try to remedy that on the third day. If you leave everything for the last day of this test, that's gonna be rough. So this will consume the rest of our week, at least, and then I'll have to check whether, I don't remember if I've given 4 days or 5 days or a mix thereof, but today's Monday, so you got 4 days this week. So certainly this week is consumed by just doing this at whatever pace you do it. Anything more on the record before we cut it?
What was the answer for 127?
Answer to 127 was an 18.12 and a 75,295. Any guidance there?
What was the equations you used for this?
So the first thing I did was 14,000 equal 10,000 e to an 8k, and I went to go get the k. Did you jot down what your k was?
It's a 4.98.
No. You'd want to divide the 10,000, do an ln, divide by 8, and it's not what you said. But if you get the wrong k, then you're just done. Anybody something else to do while he's pushing buttons?
Is the ln of 1.4 divided by 8?
Do the ln of 1.4, make sure you either close parentheses or hit enter, and then divide that random number by 8 to get a new random number.
0.052.
That's a win.
Okay.
Do you need me to keep talking, or do you think you're okay from there now that you have the k?
Yeah, I can keep going.
Okay. So did you have a thought on how to approach the next one?
You make it 30,000.
30,000 equals
10,000 e to the k we got.
yeah. And then a t. But you'd want to actually use the 14, not the 10.
Yeah, if you use the 10,000, you just have to subtract
The
8.
10,000, you'd have an answer that's off by 8 years ago.
Okay.
So you just have to subtract 8.
You could use that, but yeah, you'd have to subtract 8.
So that's what I did, is I used the 10,000.
If you use the 14,000, you'll get directly to the answer. If you use the 10,000, you're 8 years too high.
Okay.
You get that? And then for the third answer, if you want to use the 10,000, your time isn't 40.
It's 32. Or it's 48.
It's 48. If you want to use the 14,000, your time is 40. And you can get your prediction from either of those. If you want to be safe, do them both, and if they agree, you walk away knowing everything was right. And if they disagree, then something happened wrong and retrace. More info, or is that enough?
I think I'm good.
Anybody else, anything about the worksheet from beginning to end?